All right, I'm going to start a little different on this. I'm going to show you your homework because your homework's a little clearer than your actual practice problems in your packet. But I want you to be really careful reading the instruction. This says simplify. This says solve. Okay, now look. The problems that say solve, they have an X, has an X, has an X. The problems that say simplify, they don't. But the word simplify means solve for X. Now, if you have not watched my pre-lesson, you are being silly. So stop this right now. Watch the pre-lesson because I'm going to teach this assuming you've seen the pre-lesson and I make all the sense in the world for you so you can understand logarithms. So they should have put the word simplify in here, but we'll show them some forgiveness. And so simplify means what? Solve. Solve for what? X. Well, there is no X. Exactly. So that's the first thing you're going to do is put equals X on every single one of these. And then remember what I showed you on the pre-lesson. Start here, go here. This is your base. This is your exponent. This is your answer. Now, I am certain that if you've been listening to math along the way, you should be able to figure this out by just looking at it. 2 to some power is 8. Well, that has to be 3. But let's act like we don't know that, and I need to brainwash you for some of these harder problems. So this little phrase, common bases, happy places, is going to get more and more important today. In other words, I got a 2 as a base and 8. I need these to be the same. So I'm going to take the bigger one and make it equal the smaller one. So that's going to be 2 cubed. And then the 2's cancel, and I go, aha, x equals 3. Okay, we're going to do the same thing with this one. Put my x in, start here, go here. That's how you do it. 5 to the x power equals 25. If that confuses you, you better watch my pre-lesson. Common bases, happy places. So I'm going to stick with that. 25 is going to turn into 5 squared. Now these bases just disappear. X equals 2. And now, look at this one. Put in x. Start here, go here, then here. In other words, 4 to the x equals 64. And I'm sure you guys can figure out that this is 3, but I'm going to get you guys practicing. Whoops, 4 to the x equals, I got to change that 64 into 4 to some power, so that's cubed. And then those 4's disappear, so I get x is 3. Over here, equals x. Now this one's unique. 3 to the x power equals 1. There's no way you're going to find common bases, so now you got to use common sense. So what power does this 3 have to be raised to get a 1? Well, common sense, it's got to be a 0. Anything to the 0 power is 1. Go on to this one. This one's so easy. 3 to some power equals 3. Now, isn't there a little invisible 1 there? We got common bases, so x has to equal 1. Moving on. Seeing the pattern? Start here, go here. So 3 to the x power equals 81. Common bases, happy places. So that'd be 3 to the 4th power. Then 3's disappear. X equals 4. This one's going to get a little trickier now. So we put an x in here. Start here, go here. This turns into the base. This turns into the exponent. This is what we refer to as the answer, is right here. Now there's a couple ways to get home from here, but we're going to stick with the program, common bases, happy places. So I know that there's a 1 there. And your brain has to be able to do math in multiple directions. So that would be 1 over x squared. So if it looks like this, and I put it where it ain't, the negative goes away. But if I take this and bring it up, I have to put a negative in. Why am I talking about that? Because we're going to bring this above the division line, so this turns into 5 to the x equals 5 to the negative 1 power. And then the 5's cancel, and we get x equals negative 1. See, that one was a little tricky. And they're going to start getting a little trickier. So we put an x in, start here, go here, always 3 to the x power equals 1 over 27. I got a 3 for a base, and I have a 27. 90% of the time, you just make the bigger base same as the smaller one. So step 1, we're going to turn that 27 into 3 cubed. Just like the previous problem, I need this thing upstairs so I get common bases. So it's going to be 3 to the x equals 3 to the negative third. These cancel. X equals negative 3. There we go. Now we're going to throw in some square roots. Base, exponent, answer. So that's a 3 to the x power equals 9 square root of 3. So this is just getting messier. This is a 3. This is a 3. That's a 9. So I like this. I don't like this. So I'm going to change the 9. So 3 to the x equals, watch this, 3 squared. And I'm going to tweak this because that's a 1. And there's a little invisible 2 in there. So I'm going to write it as 3 to the 1/2 power. Now concentrate on this side. When the bases are the same and you're multiplying, you add the exponents. So I know some students would go like this. They'd go 3 to the x equals 2.5. So that'd be 3 to the 2.5. It's not wrong. It's just not what Algebra 2 does. So 3 to the x equals 3 to the 2.5. Again, not wrong. Probably not what Algebra 2 does. 3 to the x equals, and then they're going to turn it into an improper fraction. 2 times 2 is 4, plus 1 is 5. So we get 3 to the 5/2. All three of these are perfectly fine, but Algebra 2 is probably going to go this way. And then the bases cancel, x is 5/2. If you said 2.5, that'd be fine. If you said 2.5, that'd be fine. But this is the way Algebra 2 is probably going to take it. Go on to here. Got those darn square roots. Base, exponent, answer. I got a 2 and I got an 8. Which one's bigger, Sesame Street? The 8. That's what we have to change. We've got to try to make it a 2. So we're going to go 2 cubed to the x power. Now we got power to power, so we multiply. Whoops, that needs to be a 2. To the 3x power equals, now watch what I'm going to do with this. There's an invisible 1 there, and there's an invisible 2 there. I'm going to take advantage of those and go 2 to the 1/2 power. My bases drop out once they're common, and I set the exponent equal to that exponent. So 3x equals 1/2. What am I going to do? A lot of students would say, well, divide both sides by 3. I agree. But I bet you if I divided this by 3 and divided this by 3, a lot of students would screw this up. So instead of dividing by 3, I'm going to multiply by 1/3, multiply by 1/3, which is the same thing as dividing by 3, but the math is a lot easier. And so x equals, try to cross-reduce, swoosh. I can't cross-reduce, so I just swoosh. Multiply straight across, 1/6. All right. Hopefully you're starting to get this. Base, exponent, answer. Notice I have a 5 and a 25. Which one's bigger? The 25. What am I going to make that? I'm going to make the 25 5 squared. Now, I'm going to make this 5 to the 2/3 power. And then the 5's cancel. X equals 2/3. Done. All right, now we're going to put an equals x in there. Base, exponent, answer. Now watch this. I got an 8 and I have a 2. This needs to be a 2, base 2. So we're going to turn it into 2 cubed. But this is 2 to the first, and I need to bring it upstairs. So it's going to be 2 to the negative 1 to the x. And then we multiply these, so we get 2 to the negative x equals 2 to the third. Now that we got common bases, they can just go bye-bye. So negative x has to equal 3. Negative x equals 3. That means if I multiply both sides by negative 1, x equals negative 3. Done. So examples 1 through 12, the instructions were simplify. How come? There was no x initially. You had to put it in and then solve. These, the instructions should say solve. I just think she forgot to type it in there. So this one's actually easier because it's got all the parts. So 5 cubed equals x. Don't forget, it says solve. Solve for what? X. Well, we're done. But I bet you 5 times 5 times 5 is what Algebra 2 wants. So this is probably what is going to be in your Schoology answer. So start with here, the base. There's my exponent. So 2 to the 3.5 power equals x. So this is not wrong. It's right. But Algebra 2 is not going to be that kind to you. So this one has a little bit of trickery in it. And that means this is 3.5, which is just the same thing as 2 to the 3.5, which is the same thing as 2 times 3, which is 6, plus 1 is 7. So it's 2 to the 7 halves equals x. Now, what does that mean? That means that it's the square root of 2 to the 7th, which is the same thing as 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. 4 times 4 is 16. Times 4 is 64. Times 2 is 128. And then we're going to break that up into 64 and 2, which is 8 square root of 2. That one gets the Mr. Nasty award for sure. So this is your base. Last problem. 1 over 25 goes to the exponent. Negative 1/2 equals x. So all we got to do is figure out what this is. What I'm going to do is obey that negative first and flip the fraction, which is just 25 to the 1/2 power. And then what's the 1/2 power? It's the same thing as the square root of 25. And what's the square root of 25? 5. Done.